this Friday, Friday, and together with that, you have to give the peer evaluation. The peer evaluation, which due on this Sunday. Okay, that's first thing on assignment. So thank you very much, Faris. You're asking whether you're very concerned on me, whether because probably you heard my voice are not very smooth. Okay, don't worry because I actually rushing to finish my breakfast, and I haven't taken enough water on that. Yeah, hopefully we all stay healthy, stay safe and healthy. So the most important thing is you know that something I want to remind you when our campus become reactive with all the students coming back, it's actually create a very good situation for the virus to transmit. Okay, so because all of you coming from all over the place in Malaysia, that's the first thing. Then the second thing is because many of you are actually living in campus, or you are begin to say probably you rented a house somewhere outside campus, but you still live together with your friends, your classmates and so on. So this actually create a very good venue for virus to transmit. So, and the third one is because of because the venue for your lectures and also the lab are actually plotting. So you do not like it does not like a secondary school or primary school where they have the same venue at all times. So it's actually create another possibility. I mean the risk of infection is higher. Then what else? You probably have a higher, a largest circle of your activity, because if you compare to primary and secondary school student, they only can go out together with their parents, but you are very free. You want to go anyway, okay? You are very free to. So it's again increase your risk of infection as well. And also our lectures hall are actually confined space with aircon, air conditioner, and everything. So these five condition actually increase the risk of infection. So I studied disease transmission, so I can tell you on that. So what you need to do here, of course, is to take care of yourself. Okay, have enough water, enough sleep, enough enough water. Okay, and if possible, wear mask. Okay, wear mask whenever you mix with other people. So that's my suggestion to you. Okay, that's my suggestion because especially you have to consider although now the virus might probably not as that silver compared to Delta variants, but many people can't afford to even quarantine, like because quarantine will reduce the productivity and because and yeah, that's something. I'm very worried on this virus because I live with my my mom who is already in is quite old already, and I have my kids as well, so I have to take extra precautions measure to myself. Okay, so that's why I choose to have this online class instead of physical. And another good news to you. Okay, another good news before we start. Manual attendance, no problem. Patrick, at 0944. At 0944. There is a very high chance that I cannot conduct class on next Tuesday. On next Tuesday afternoon, I will reconfirm with you probably by Sunday or probably by this afternoon because I was asked to attend an official function at Hilton Kuching in the afternoon of next Tuesday. So I don't like to go
and because I have to cancel this class. Okay, so probably a good news to use, but we are still ahead of schedule, or probably it's still on schedule for according to our planning, so shouldn't be a problem. Is okay? So I will. So any others manual attendance requests? So far I have 3. All of you 5 absent. So who are this? Who are the absent? So any one of you need? Yeah, this one I have to check this. Okay. So okay. Okay. So this online lectures will be recorded. Okay. So we enter our third main learning unit. Okay. Which is vector value function. From the name itself, then you should know that. Okay. You should know that we deal with function. Whenever we deal with function, you should know that it is relation one-to-one, it is relation many-to-one, things, and also we can't have relation one-to-many. So the word function, as a student major in mathematics and also computer science, you should be able to know the characteristic, the definition of function. So then we have this the word vector value function. Vector value function. So basically, let's go for this a little bit of definition. Okay. So here you have you know that what we mean by vector. What we mean by vector is basically you have the magnitude as well as the direction. Okay. In pre-university or even in your secondary school, you have many notation for vector. You can use ball, you can use the hat symbol, or you can use this one. Or you can use A, this is also mean vector, or you can have your direction directly O to A. So in other words, we have a magnitude. Let's say you will have something like this 3I. Okay, I'm using this one plus 4J. So this is a very typical vectors vector that you have, okay, in your secondary school and also pre-university. So this will tell you that the magnitude, of course, how you get the magnitude is you have to find the modulus. You have to find the modulus where you have to use this 3 power 2 plus 4 power 2. Okay, then you have the answer here is 25 square root, and the answer here is 5. So this 5 tells you that it is the magnitude. And the direction will be given, you have to plot that. Let's say this is your 3, this is your 4. Okay, so this is the direction. So this is your OA. So this is your metric OA. So this is your direction, roughly 35 degree or whatever degree from here. So so that's about vector. Vector, you have the magnitude and direction. The opposite for vector is called scalar function. The scalar. The scalar here is only have magnitude. It's only have magnitude. Let's say you have 4 centimeter. So that's obviously that is a scalar function because you only have magnitude. Okay, you do not have that direction. So what we do here for this, so this is scalar, this is vector. So what we want
to have here the vector value function is basically we are using function. Whatever function is function in terms of t or whatever. Okay, in the vector form. So what we have here is if I change this a little bit, I add a little bit on this. Instead of using 3, but now I'm using 3t. So this 4t are using 4t power 2. So where this one, you know that this 3t is actually a function in terms of t. Okay, so this is also a function in terms of t. Okay, whatever. Of course, you can have any variables. Okay, you can use any variables t, and you can use even 2 variables here. There is no problem if you want to use s and t. Okay, that's no problem. So you have a vector, okay, but the vector here, what you put in your component I and j and also your k here, it is not only the scalar, it is not only number, but it is a function. Does that make sense to you? So this is vector value function. Okay, thank you for response from Faris. Okay, Rebecca, thank you. Okay. Thank you, Veronica. And so this part here, even though we do this online, but I did not. I mean the teaching content, everything, the quality should be the same as we do our class face to face. Okay. So, but you have to always remind me if I go too fast. Okay. If I at least you give some response. Okay. So some of you may have problem in your internet access. Hopefully you have your stable internet access. Okay, so that's about the definition of this vector value function. Okay, the vector value function. So we have this or usually we call it the R. Okay, you can use any alphabet you want. So this is function for this is a vector value function for 2D, where it is in plane. So if you have 3D here, you have your space. So this is just the top. Oh, suddenly I heard. What's wrong with? It's quite scary to hurt my voice. Okay, on the echo. I think probably some of you, not sure whether it's me. Also now it's okay. Okay, so the shorthand here is you have your D symbol. Okay, you have this symbol, but just to avoid of writing I and J and K every time, we can use this another alternative symbol for vector value function. So what we are going to look at this here is actually again, okay, graph. Again, graph. We are going to sketch this vector value function in 2D, the 2D graph and also 3D graph. But in some of the question that we are going to, some of the vector value function, we make use of parametric equation. Okay, so later on, we will have revision on this parametric equation. So that's about first part of this vector value function. It's a very short chapter. Then the second one is involve some operation. Operation involving vector value function. You have limit, differentiation, integration, dot product, and cross product. So this thing here, it is just similar to what you did for your calculus. You have your differentiation, just that you need to go for component by component. You need to go for component I, component J, and component K. Then you actually do the operation. And we have two applications. The first is, or interpretation, the first is on the unit tangent vector, normal vector, and binomial vector. So we have advanced formula to follow, but it's actually just a differentiation. It's actually just a differentiation. So don't worry. Although I will not give you this formula, it is very easy as long as you know that it is doing in differentiation. And the second application is on this finding velocity from the position vector as speed and acceleration. I think this one you are quite familiar with that. Okay, and the third application is actually arc length, but I don't think I will go for that. I may skip this because this is very engineering. This is very engineering. So this is a very short chapter, probably 2 weeks time or 4 lectures. We can cover all this. 4 to 5 lectures. Is it okay? So move on here. So the first thing is we need to have this sketching tree, a vector value function. Sketching vector value function. Before we sketch this vector value function, that I think we have to do some revision of parametric equation. To do some also. So you have this parametric equation. Look at this. You have this. If I write this parametric equation, it is x. It is x equal to 3 minus t. Then you have y equal to, I put my 2t here, 2t, and you have z is equal to 3t minus 4. I put it as negative 4 plus 3t, plus 3t. Okay, so this parametric equation is you have to be very careful here. I can put here as 0 plus something. I can put it as 0 plus something. I just want to put it in this form. Okay, where you have the intercept together with the coefficient on the t. So a few things that you have to you should notice that this is the standard parametric equation. The word parametric equation meaning to say that we use parameter t. We use parameter t. Of course, it can be various type of parametric equation, but this is the simplest type. So why I say this is the simplest type? Because the t here, everything is power 1. The t here, everything is power 1. So it is very important that we restrict ourselves to something t power 1. Of course, if you have t power 2, it is still a parametric equation. If you have square root, if you have sine t, whatever, it is still a parametric equation, but not the standard parametric equation that we are going to use later on. I hope it makes sense to you. Okay, when we talk about parametric equation, as long as you have a parameter, you have a parameter t or whatever alphabet, if you want to use alpha, beta, or whatever, you can. Okay, so as long as you have a parameter, that's one thing. So, but for this case, we focus on the parameter t which have power 1. Okay, we have power 1 here. So it is also possible if we do not have this. Suddenly we have this one. Okay, we do not have t here, which is fine because it can be, okay, it can be plus 0 t power 1. It can be like that. Okay, which is 0, the coefficient 0 here. Okay, so, but we are not going to use for this one. Hopefully you can follow. And then here you have your minus t. You have your minus t. So that's one thing, parametric equation. So it is very important for you to know that this equation, even though they have 3 equations, x equal to something, y equal to something, z equal to something, even though they have 3 equations, these 3 equations represent one line. I use red color. It's only represent one line. Why? So what do we mean by t here? Let's say let your t is time. Let your t is be time. It is time, whatever in second or whatever unit, the time unit. So if you have t equal to 0, notice that if you have at t equal to 0, this is for my explanation only. t equal to 0, you know this part are all 0. You have the x equal to 3, y equal to 0, and z equal to negative 4. Okay, so you have your x, y, and z equal to 3, 0, negative 4. Is it okay? You have a point. Then if you choose at t equal to 1, if you choose t equal to 1, you have another point. Okay, you have another point here. This is 1 here. It is 2. Then here, this is 2. Then here, this is negative 1. You have a point. So t is time. It can be any time that you can have many value in between, even in between 0 and 1. You can have 0.01. You can have a lot. Okay, you can have a lot here. You can have many t equal to 2 a lot. Okay, if you want to type negative, you also can. So from here, you should see here, this is a set of points. We do not know which point, but it will contribute to if you have so many points here, then you can see the line here. Of course, you have to be very careful of the word line here. It actually means that it is a curve. It does not necessarily, but in this case, in this case, it is a straight line because it is power 1. So it is a represent, to be more exact, represent a straight line. Why it is straight line? Because this is t equal to 1, power 1. I hope I'm not too fast. I need to give you some time to digest this. Okay, so I repeat. Although it looks like we have 3 equations, it only represents one line. Or to be more exact, it represents one straight line because of power 1. If you have power 2 and so on, then it can be a curve. It can be a curve. Okay, like I show you, because you have so many points. If you replace it with your parameter t, you give a value to your parameter t, then you should have many points there. Okay, then what we should do, then what sort of information we can get from here as well? Okay, we can get this information directly. It is very two information then we can get. It go to, from here you know that, okay, the line goes through, if you goes through, salah pula. The line go through 0.30 negative 4. The line go through 3 because it's very easy. You just ignore. You just put in your t is 0, 0, 0. So you are getting this point immediately. Okay, so with that, you can have your point already in your 3D graph. It's very bad. Wait a minute. I don't have to put so fast here. Okay, then. Okay, the x and y and z here. So let's say this is 3. 3 is somewhere here. 0 is somewhere here. So negative 4, I may go down a little bit on this. I say that this is my negative 4. So the point is somewhere here. So this is the point. This is 3, 0, negative 4. Okay. So the first information, we get this. Then the second information is very easy. We just focus on this part. the coefficient for your t. That's the second information. So this also means that, okay, the line, this is your first one, this is your second information. The line is parallel to this one, a vector, whatever you want to call that, a vector v. I call that is a vector v. Okay. And it is equal to negative I plus 2j plus 3k. Okay, so by taking the coefficient of t, of course it is negative, you have to take the negative. So the line is parallel to this vector. And this vector will show you the direction, right? Because you know that this vector, this is a vector, this is not a vector value function. Be very careful, this is a vector. So the vector have negative I. Let's just simply plot that this is a negative I here. Then you have your 2j. So 2j somewhere here. Okay. Then I increase this, I bring this out to 3. I would say something here. So let's say it is here. Let's say. Okay, so this is my V. Hopefully you're okay with that. Okay. Are you okay with this? You have your V. Okay, thank you for response. Then what we have here, okay, so you have your vector V. So now you can sketch this vector value function according to this one. So it's roughly you sketch that this is somewhere here, or you have a line. But remember, it is very, very important for you to put an arrow here. We assume that it's going this way. It can be another way. It can be another way. But as long as you have the arrow state, then it is fine because you know that this is the vector value function. This is the vector value function. Is that okay? So I'm going to move to this, the first example. So that's just now is for you to familiar with parametric equation, the use of a parametric equation in this vector in sketching vector value function. So if no question, then I move on to our first example. So we want to sketch this graph of vector value function. So from here, what you are going to say here, you can say that this is your x, okay, this is your xt. If you want to, this is your yt, okay, and this is your zt. This is your zt. So that's why you have a parametric equation, x equal to 2 minus t. Then I have my y is equal to 3t, okay, and I have my z is equal to, I shift this a little bit, negative 6 plus 2t, negative 6 plus 2t. And immediately, if there is a need for you to put this is 0 plus, or 0 plus 3t. Then from here you know that this, I will not write in too detail, but I know that this is passed through. This passed through a point 3, 2, 0, negative 6. 2, 0, negative 6. Very similar to our previous example. So I can have my 3D graph. X and Y and Z. So here you have a 2. 0 is still here. -6 is probably somewhere down here. Okay, yeah, then this is the point. So this is the point, 2, 0, -6. Don't too worry of this. If your point is somewhere here, it's still okay. As long as it is not here, not here, not here, then I accept. Okay, whether it's not really in proper scale. As you know, I don't like to mark your calculation. A lot of this what are you going to say? What do you call writing? A lot of symbol, mathematic formula. But I like to mark your graph. To me, graph is very easy to mark. Okay, so of course you will have this kind of question in your test 2 or your final exam. Sketching graph or vector value function. Oh, janji. Kevin said janji. Memang janji. So then the next one, this is your pass through this. And I use this symbol. I hope you can use this symbol as well. Parallel. This is parallel. So parallel to a vector. So parallel to a vector, the vector is very easy. You just look at the coefficient for your t. Okay, look at the coefficient. You know that it's parallel to -I plus 3j plus 2k. -I plus 3j plus 2k. So you can have your -I somewhere here, -1. Then your 3 probably somewhere here. All what you need to do here is increase to 2. Oh, because the 2k here. So you may have probably this one. So you can have a parallel vector. This is your V. This is your V. Okay, then then you know that this graph should be something like that. Or this graph should be something like this. So you simply say that this is going that direction. Of course, you can try to find that, okay, to verify whether it's going that direction or this direction, okay. You can do that. Oh, but I don't think I'll not be very strict on this. As long as you give this arrow is very important. For this question, you need to have this is getting this correct. You need to get this correct. You need to have this line together with this arrow. One of these arrow must have, okay? Because this is just for your line, but this will tell you the direction. This is very important. Of course, you need to list down this parametric equation. Any question? So hopefully you get this idea here. But I have to admit that the drawing, the sketching of this vector value function, especially in 3D, somehow is not that meaningful. We do not have physical class. Otherwise, I will give you the direction on the 3D space. What we sketch here is actually we're putting a direction into 3D space into a 2D, because our on paper, your paper, this whiteboard, whatever is this screen is 2D, right? It is somehow difficult for you to really see the correct direction. But that is the limitation. We draw something, we draw a 3D direction in 2D space, in 2D plane. So that's the limitation. As long as your graph is not something like this, not going like this, okay, or then it's fine for me. It's fine for me. So is that okay? I kind of summarize this a little bit. Okay, this is vector value function. Hopefully now you can see here. This is a vector value function. It's different. You can distinguish it from vector, where the vector here, the component I and j and k are all numbers, but now you have a function. Oh, that's it. Oh, that's why it is called a vector value function. Vector value function. So you have this. So you can have vector value function in 3D. You can have in 2D. Or you can have your t here parameter is in whatever power 2 or power 3 and so on. But if it is in power 1, if they are all in power 1, okay, then you have two information. You know the line will pass through certain point and we parallel to certain, what do you call, certain vector. Okay, so that's about parametric equation. Just to share with you that this parametric equation can also be written in the symmetry form. It can also be written in the symmetry form. You know that why we need to put it in this way, because instead of using three equations, then we only use one equation, one line, one horizontal line. So this is very easy for you to convert that. From here, you can see here. You can see that the denominator are all the coefficient for t. Yeah? The denominator are the coefficient for t. You have -1, you have 2, you have 3. Then this is x minus 3. This is actually y minus 0, even though we didn't write. Then you have the z minus -4. You can put it in this form as well. Okay, of course, this form will probably slightly difficult for you to get the information that you want, go through the point and also parallel, but this is another equivalent form of a parametric equation. And of course, you didn't see the parameter t here, but it is equivalent form. This is just for your information. Okay, so thank you, Kelvin, and let's go for one more example before we have a break for 5 minutes. This one. Okay, this question is vector value function, but you have to be very careful. Now we have t power 2. We have t power 2. We can still write that into a parametric equation. It is still a parametric equation where you can write it at x equal to t, and your y is equal to x equal to 3, your y is equal to t, and your z is equal to 2 minus t power 2. This is still a parametric equation. It's still in parameter t. Yeah? It's still in parameter t, just that we have something power 2. It still represents one line, okay, but it is difficult for us to say passing through any point. Yeah? It is difficult. So this is still, I would like to highlight this a little bit. Okay, this is still represent one line. One line, or it can be a curve now. Can be a curve. It's a curve. You know that parabola is a curve. Then, but it didn't go through whatever point, go through whatever point here. This is not. This is not. We do not have that information. So what we are going to do here is to try to eliminate. Okay, the method to do to have this graph is to eliminate t. Okay, so that's our target. We want to eliminate t. Of course, this one you still know. You need to know that this is still in 3D graph. Okay, 3D graph. So how to eliminate t? Okay, you have your, let's say this is your first equation. Let's say this is your first equation, this is your second equation, and this is your third equation. So what I'm going to do here is I substitute my second equation into the third equation. Okay, yeah, I substitute my second equation into the third equation. So what we have here, we have z is equal to 2 minus, I replace my t with y, so I have 2 minus y power 2. This is 2. This is 2 minus y power 2. So this 2 minus y power 2, z equal to 2 minus y power 2 might be slightly difficult for you to sketch, but you can always use y equal to 2 minus x power 2 to sketch that. You can always start with this. So how to start with this? You start with y equal to, this is your x, this is your y. So you start with y equal to x power 2. Then you reverse it. You reflect it at y-axis to reflect that it is y equal to negative y power 2. So we start with y equal to x power 2. Then we have this y equal to negative x power 2. And finally, you add 2 here in order to get this. So it is something here. This is 2. Of course, you can find what the intercept of this value, what this intercept is. So this is y equal to 2 minus x power 2. But this is z equal to 2 minus y power 2. So what you need to do here is you change this to z, you change this to y. So this become your y, this become your z. So this is how we sketch this z equal to 2 minus y power 2. I hope you can follow this. Okay, thank you, Veronica. Okay, so once you have this, you can actually putting this curve in a 3D in a 3D axis. X and Y and Z. Okay, if I put this everything, okay, then I will have this. You know that this is somewhere here, or the curve is somewhere here. This is 2. Of course, you can find the value of this if you want. I think if you solve this, you know that this is surd 2 and this is negative surd 2, or where you can just let your z is equal to 0. If you let z equal to 0, you have your y power 2 is equal to 2. Then you know that y is actually plus minus surd 2. If you want to find that, but it's not that essential. Okay. So this graph at this moment, it is only consider second equation, y equal to z and y equal to t and z equal to 2 minus y t power 2. Okay. We haven't considered this. We still have this x equal to 3 to consider. So it is just very easy. You just move this curve up to 3 here. Okay. You may just move this everything into here. So you can have this. You can say that the curve is something here. Okay. So this is here. This is 2. So this is the RT. This is the RT, then you may simply give a direction. Let's say you give this direction. Now, of course, you can find the direction whether it is really this or not, but I'm not very particular on that. Okay, so this is the vector value function. Of course, you can extend here, go down here. Okay, so this one. Again, yeah, we mark your work. Say if you have this, okay, if you have this,
And if you have your this correct, okay, if you have this correct, and if you are using this what do you call getting this x and y and z, and you are using substitution, because this is very important. This will give you if you eliminate your t, and so that you can have your curve. Any question? Okay. Thank you for response. We have a break for 5 minutes. Yeah, we have a break for 5 minutes, and I will show you the QI attendance for those who need to scan that. Okay. So you may have a break for 5 minutes.
Okay, let's continue. I will start at probably 9:40 because I know that you may have to travel around campus to attend your class at 11. I'm not sure whether the 11 o'clock class it is still online or it is physical online. Okay, so if you can see here what we do here, okay, what we do, there are at least two way. There are at least two way for you to sketch this graph. The first is to use the parameter equation, the standard parameter equation where the t are all value all power 1. If they are other than power 1, if they are power 2 or power what you call a third and so on, okay, then you have to eliminate t, or you have to eliminate t. So how about this question? Okay, this question, the third question, it is 2D. It is 2D, so what you need to do here is you know that this is your x, okay, this is your x, okay, this is your x is equal to 2t, and this is your y, which is equal to t power 2. Okay, then you know that your idea is to eliminate t. Okay, so you have your first and second. So from here, you notice that your t is equal to x over 2. Then when you substitute into your y, substitute into second, you have your y is equal to x over 2, everything over 2. So it is just equal to 1 over 4 x power 2. So instead of sketching a vector value function, so now it is actually sketching of this parabola, sketching this parabola. So what you can do here is you go for your x and y, and you know that this is parabola, but just probably this is wider or this is narrower. So it is still a parabola, where it is given when t is equal to -2. Well, notice that you need to go for t equal to -2 to 2. So you may say that when t is equal to -2, okay, you have your value here, which is xy. The xy point is equal to -4, 4. Okay, so you may simply say here this is your -4, this is your 4. So this is at t. This point is happen at t equal to -2. And when t is equal to 2, you have your xy point again. You just put into here, you have your 4, 4. So this is another one. Here is 4, 4. So 4, 4 here, t is 2. So obviously from here up to here, you know that this now we are very sure that the arrow is this direction, not the other way around. So this can be quite if you have this parabola, then it's 1 mark. If you have this here, it's 1 mark. Then sorry, this is 4. This should be 4. So here is 1 mark. Here is 1 mark. 1, 2, 3, 4 is already here. You have this one, and you have the substitution. Okay. So what you can you should know at this stage. Okay, at this stage is in your pre-university you deal with vector. Oh, you have this kind of vector, whatever vector or whatever. Okay, this vector is basically it shows you that it gives you the magnitude, so how strong it is. Okay, and also the direction. Okay, so that is vector. Oh, that is vector. But now you have this. this thing is vector value function. Okay, this thing is a vector value function. Vector value function. So you should be able to see here, this vector value function can tell you, I'm not sure whether you agree or not, can tell you the movement. Okay, or there is an element of this animation there. It depends on your t value. If your t value is -1, -2, probably here. Then if you have -1.9, probably here, and you can see, you can have a movement then. Is it okay? I hope you agree with me that that's why you can say that this vector value function can be used to show animation, to show the movement. Okay, hopefully you can get the ideas why you need to have this vector value function. Previously, vector is only magnitude and direction. Now you can show your movement, animation, and so on. Ooh, we may have an assignment on this. Okay, to use this vector value function, and you drag it in some coding, and then to see the animation there. Ooh, do you like to have that kind of assignment? Oh, Veronica said don't want. What is that, Patrick? Patrick are looking on, anticipating on that. Okay, so this is our third example. Okay, now we will go for something that is my favorite. This question now. This is my favorite. Okay, so this is still a vector value function. Then you can still get your parametric equation. You can still get your parametric You can still get your parametric equation where you have your x is equal to cos t, y is equal to sin t, and the z is equal to t. So this type of function, the vector value function, has a very unique name. Later on, I will tell you. So the parameter are now is in, some are in the t, but some are in trigonometry. We have the trigonometry, cos and sine. Okay, so this is again my favorite. I hopefully you can follow this a lot. Okay, carefully you follow this. So you have your cos and sine here. What you can see from here, if you have your cos and sine, okay, this cos and sine, if you combine these two, okay, if you combine these two cos and sine, and if you are trying to find x power 2 plus y power 2 on that, okay, what you will get here, you will have your cos power 2 t plus sine power 2 t. And you know that this is equal to 1. So in many cases, you will see this cos t and cos and sine t, and you have to make use of trigonometric identity, okay, to make it become 1, or you can say that 1 power 2. And you get this x power 2 plus y power 2, and you know that this is a circle or a cylinder, radius 1. Of course, center 0, 0, center at this 0, 0. It can be a circle, it can be a cylinder, but we prefer to go for cylinder because our vector value function are in 3D. Okay, so you know that this is a vertical cylinder rather than a horizontal cylinder because there is no jet. You didn't see any jet there. So you can have a vertical cylinder, something like this. Of course, it's extend to the negative infinity. Yeah? So how big is this? This is here is 1 and 1. Okay. So after this, okay, I hope I'm not too fast. So you have the cos and sine. Then after this, you have your z equal to t. Okay. So what you need to do here? Okay, you need to construct a table. You need to construct a table where you say that this is your t value. This is your t. Okay, and you are trying to get your x and y and z point. You are trying to get your x and y and z point. Of course, you start with 0. You start with 0. T equal to 0. You start with t equal to 0. If you start with t equal to 0, you will get your x here is cos 0. Then you will have your sine here is sine 0. And your tz here is 0. Where this gives you 1, 0, 0. Is it okay? We start with t equal to 0, and you know that cos 0 will give you 1. This is optional. You don't actually need to write down. You can straight away give this is 1, 0, 0. If you are very sure that the cos 0 will give you 1, sine 0 will give you 0, and this is of course 0. So with this, you can have your first point, which is located at 1, 0, 0. So here is 1, 0 is still here, 0 is still here. So this point here, it is given as a t equal to 0. Then you have the point 1, 0, 0. Of course, it is not really needed for you to write down this. You have your t is equal to 0. The point is equal to 0. So what is here, you denote that this is at t equal to 0. It's more than enough. So of course, you can go for many different t value. You can go for 0.2, 0.4, 0.01, or 1 and 2. But it is not that convenient if you go for 1, 2, 3, 4. So this is more convenient if you go for t equal to pi over 2. Then you go for t equal to pi. Then you go for 3 pi over 2 and also 2 pi. It is sufficient if you go for this. If you go for this. Then I will not write this down. I straight away go for here. You know that cos 90 degree, you will have 0. Sine 90 degree, you will have 1. Then here, z, you will have pi over 2. I repeat, this is 90 degree, cos 90 degree 0, sine 90 degree 1, and then you have pi over 2. And similarly, you know cos pi will be negative 1. Okay, and you have the psi pi is 0, then here is pi. You have your 3 pi over 2. So 3 pi over 2 is cos 0 again. Then psi 3 pi over 2 is -1. Here you have 3 pi over 2. And then you have 2 pi. Cos 2 pi here, you know that it will come back to 1. And then sine 2 pi is 0. This is 2 pi. Okay, Rebecca have a question that how many t value do we need to put in the graph? It depends. I think this is sufficient. Okay, we choose this value for convenience. Of course, you can have your pi over 4, but you don't actually need. I think most of the time, this pi is more than is enough. If enough, you go for 0, pi over 2, pi, 3 pi over 2, and 2 pi. Because you know that if you proceed again, this cos and sine is actually a periodic function, right? If we go back, okay, the value we go back to this, go back to this, go back to this for your x and y. Okay, I hope I answer your question. So it is sufficient. Usually, this is sufficient. You don't have to go for pi over 4. You don't have to go for 3 pi over 4 and so on. Okay, then now you can put this everything. Okay, and your question from your next question is regarding your ABC. Yeah, the ABC. Okay, notice that question number D. Okay, question number D. The way that we do this sketch the graph are slightly different from question number A, B, C. There are different type of vector value function. Question A, it is we use parametric standard T. I mean standard parametric where the T is power 1. We have two information. Okay, so that is first group of this vector value function. Question number B and question number C are the second group, where our way to deal with this is to eliminate T. Okay, then eliminate T is like you are plotting the graph, right? You are plotting you are sketching your graph, your curve and so on. But this question number D, there are different type of vector value function where we construct this thing. Whereas in your previous question, A, B, C, I didn't show you that you have to construct this. But for this question, when it's involving trigonometry like cos and sine, I strongly recommend you to construct this table. Is that okay? So once you have the table, you put it this form one by one. So you have 0, 1 now. 0 meaning here, 1 meaning here. Okay, I repeat, x equal to 0 is here, y equal to 1 is here, but you need to go out for pi over 2. Let's say this is your pi over 2. So this is your second point. So this point happened at t equal to pi over 2. And from here, you can actually connect this already. Connect this to this one. Imagine that there is a cylinder, there is a tin here. Then you are actually your what do you call your benang is actually go along the surface or the outer surface, a curvilinear surface there. So that's you get this one. If you proceed with the next point, -1, 0, pi. So -1, it might be here. -1 is going to here already, -1, remember? Because this is +1, this is -1, but you don't actually need to put out here. Then -1, 0, pi, now it's even bigger. I mean, even higher, let's say here. So this is happen at t equal to pi. So I will use a dotted line, or it depends on you. It's just to tell you that this line is actually at the back of the thing, at this cylinder. Hopefully you can see. Of course, if you want to use a full line, then this doesn't matter. It's the same. I just to emphasize that this is the one. If this cylinder is not transparent, you will not be able to see this line. That's the meaning. Then you will have another one, 0, -1, 3 pi over 2. So 0 is here, -1 is here, 3 pi over 2 might be somewhere here. Let's say it's here. Okay, so this is up to here is 3 pi over 2, but you don't actually need this one. You may have your t is equal to 3 pi over 2. So you proceed with this. Continue then. It's still at the back. It's still at the back of this cylinder. I don't emphasize on that. If you want to go for this full line, you are okay with that. It's not necessarily that you go for a dotted line. Then we have another point, 1, 0, and 2 pi. So 1, 0 is back to here, and 2 pi maybe somewhere here. Okay, somewhere here. Then if you set that up to here, it's go this way. It's go this way. Of course, you know that it's extend to that. So what you can see here, it is this type of graph. Okay, so this is called a spiral. The shape is a spiral. Of course, this one, if you have the spiral outward or spiral downward, you can have spiral inward and so on. Oh, sorry, it must be the same big as this. You start from here, going this one as that. Okay, so it is a spiral. Okay, so these spirals, okay, movement is spiral movement, whatever you want to call it. So this function, we have a very special name for that, which is called helix. How come it is only this is correct? I'm not sure why it's give me this one. This helix function. I think I have to go for helix function. Now it's correct. So this is helix, okay? So whatever you see here, these are whole helix function. Okay, you can see here there are a lot. Okay, there are different type of helix function. Is it okay? Or if you need to print screen this one, yeah. I give you 20 seconds. So I have a few questions to ask. to make sure that you understand this topic well. I mean, especially this helix function well. Okay, my first question. If you have no question, then I ask you question. I ask my I ask my question that normally I have to answer my own question. The first one that I ask is what happens if I put this as 2t? This is my first question. The variance of this, the variance of, if I put this as 2t, anyone want to answer? What happened to this movement, or what happened to this helix, or this movement spiral, if I have 2t? All of you keep quiet. Longer, what do you mean by longer? It's longer, correct? Yeah, higher, yeah, very good. Okay, yeah, good. The spread become longer, taller, yeah, all correct. So if you have this 2t or even 3t or even t power 2, you expect that this is moving even faster. I mean higher, longer, whatever, higher, it's go higher. Taller will be the best. So that's the first question. Hopefully it makes sense to you. Okay. Hopefully this makes sense to you. If you have power 2 even faster, right? Even is crying out even faster. As we say, crying out even faster. So that's the first one. You have to know that this variance of this helix, okay? The second one, if I simply swap this, how am I going to say? If I simply swap that, I keep my t here, tj, but this maintain the same. This maintain the same. But I move my psi t here. This is my second question. So what are the changes that you made? Yeah, very good. The parallel to y-axis is parallel to y-axis, yes. Parallel to y-axis, yes. So we expect that this will be similar. Okay, it will be similar, but now you will have this one. You will have this. So this thing here, you still have to find this. You still have to construct this, but you know that basically your spiral will going this one. Okay, but you have to find the exact point to know that this is this one. So I can prove my cos and sine here. I can prove my cos and sine here. I can have this version. So, but if I simply just change the sine and cos, I put my sine here, I put my cos here, it is still a vertical cylinder, right? Just that probably the starting point of these are different. Did it make sense to you? Just now, if I say I put my psi t at the z component k, then I put this, we will have a horizontal cylinder. But if I just simply swap that the cos here to sine and then the sine to cos, it is still a vertical cylinder, but just that probably the starting point are now different. The starting point and everything, the probably the way the movement and direction and everything are slightly different. Is it okay to deal with this cos and sine at different component? But do not to worry, we only have cos and sine. We will not have tangent. We will not have secant and so on. That is very difficult for you to sketch. That's the second variance. Hopefully you get this idea. Yeah, if you go for tangent and secant, it's difficult. It is normal helix. We have no idea. I have no idea what's the function called. Get the first one, this one. I have no idea. You have to rely on how to draw this graph. You have to rely on the graphing utility or programming to help you. Okay, so that's the second one. And the third one, the third one is what happened if I simply prove this as 2t, 2t. That's my third question. Hello, are you with me? I have the cos 2t, sine 2t. Exactly the same. I just modify this a little bit to put that as cos 2t, sine 2t, j, tk. Sand height, yes. But more turning, maybe, okay. So very good, von Kelvin. If I put that a little bit complex, maybe, okay. So if you put that this is cos 2t and sine 2t, there is no difference because if you are putting that this is 2t, 2t, you still have 1. You still have this big, you still have this cylinder with radius 1. Okay, so for the third one here, it is still this. You still get this cylinder with radius 1. But the point might be slightly different. Okay, might be slightly different because this will have effect on this thing. Okay, so we do not know, then you have to construct this table in order to sketch it properly. Okay, but in general, it is still moving outward, but probably slightly slower and so on. I do not know. But the cylinder, the radius are still the same. That's number 3. For that, you have to list out this, okay, to get the graph. Okay, number 4. How about if I have the same question, but now I have, okay, let me draw this one. Let me rewrite this, everything. Number 4, cos t I plus sin t j plus tk. So all are the same, except now I have 2 outside. Just now the 2 is inside the cos and sine, but now it's outside. I think this is very obvious. What happened to our ellipse? The radius become 2, wider, very good. Okay, so now instead of going for 1 now, you have 2. That's it. But this is you have to pi this again. You have to go for that. Now your cylinder are even bigger. So this is 2 and 2 now. And but of the point, whether it's slow or faster and so on, you have to construct this table. Is it okay? So I will probably start after this, but just to tell you that these carry a lot of marks. If you list out this x and y and z, okay, then if you are using a trigonometry to get your cylinder, okay, and you have your cylinder with you, okay, you have your cylinder with you here, you have your cylinder, and you construct the table. Yeah, you have the sense of listing down a few, of course, okay. And your first point is correct, all other point is correct. Then you have your helix outwards, okay, and you have your this. You have your at least 1, 2, 3, 4, 5, 6, 7, and 8 marks. At least 8 marks. Okay, so this is the type of this vector value function, and it's very useful for spiral type of movement. And they have various variants. You have to be very careful. The cylinder. Basically, the idea is the same. You need to get the cylinder. In most of the cases, cylinder. I didn't go for this cos power 2, sine power 2. It will be very difficult. Okay. We don't have that. Okay. We restrict to this only. A few cases like this, the cos t and sine t and cos 2t and sine 2t, or this one, 2 cos t and 2 sine t, like that. Okay. So what you need to do here is, of course, to get the x and y and z component, and then try to use trigonometry to get the cylinder equation, the equation for cylinder, and then draw the cylinder. Then after that, you construct the table. Construct the table. Usually we use this few t value, but you have to be very careful of this t value, so that you get a few point and you plot it accordingly. Sketch it accordingly, get the correct point and then connect it. That is what you need to do for this helix. 3 different type of vector value function that we discussed today. Is it enough? Okay, any question? So if no question, okay, I hope you, this is important. This question is very, very important. Because I believe that this is something new for you. You first time hear this helix function, spiral things, okay. I'm not sure whether PowerPoint you have the spiral effect, right? I'm not sure whether they are using this or not, okay, to control your line, or your animation. I'm not sure. Okay, I'm not up to that level yet. Okay, but I think this is the basic. This is the basic. Okay, so if no question, you may leave this platform now and you prepare for the next. You prepare for your next class, and don't forget to submit your assignment. Okay, I think it's online, right? Okay, online and together with hard copy. I'm not sure whether you need to have hard copy. I can't remember. Okay, please read in the helix. Okay, that's all for today. Thank you. Bye bye and stay safe. And then for next Tuesday, I will post it in the CS WhatsApp group, telling you whether you have a class or not. I will only tell you on Monday, next Monday, because I do not know whether the function is still on or not, confirm, or there is no any changes of time. If I have to go for that function, then I have to cancel class. So I will let you know on next Monday, probably morning or afternoon, so that you can prepare for that. Okay, so hopefully you take good care of yourself. Okay, stay safe and stay healthy there. Okay, thank you. Bye bye.